Welcome to this explainer. We spend hours, literally, every single day staring at screens, tapping on keyboards, and letting these glowing rectangles run our personal and professional lives. But how often do we stop and ask, what exactly is this magic box? Well, today, we're going to demystify the foundations of computer science. We're going to strip away the complexity and transform the seemingly mysterious device into a simple, logical tool.
Here's our roadmap for today. We're going to cover what a computer actually is, how it functions through the IPO cycle, its characteristics and limitations, the really interesting history behind it all, the different generations and types, and finally, how they fit into modern life. Let's just jump right in. Section 1. What is a computer?
So the word itself comes from compute, right? Which just means to calculate. Back in the day, these machines were essentially just giant, glorified calculators. But technically speaking, a computer is a programmable electronic device that takes in data, processes it based on a set of instructions, stores it, and then spits out useful information. It's not just doing math anymore. It's this dynamic machine capable of everything from editing videos to running complex AI, all based on exactly how we program it.
Section 2. Functioning and the IPO cycle.
To understand how it pulls all this off, we have to look at how data actually flows through it. Literally every action follows what we call the IPO cycle. That's input, process, output. Think of input like the machine's senses. Say you're typing in a search for a nearby coffee shop. The process phase, that's the brain calculating the distance and figuring out the fastest route. And finally, output is when it displays the map right on your screen. It's just a remarkably simple, continuous loop driving every single thing a computer does. And at the absolute heart of this whole process is the CPU, the central processing unit. This is the actual brain of the operation where that process step happens. It's divided into three specialized departments. First up, we have the ALU, or Arithmetic Logic Unit. This is where the heavy lifting happens, all the math and logical comparisons. Second is the Control Unit. You can think of this one like a traffic cop, just directing the flow of data between all the different parts of the system. And third, the memory unit, which temporarily holds onto facts and instructions while the processing is actively going on.
Section 3. Characteristics and limitations. Now, while this electronic brain is incredibly powerful, it's got some pretty striking boundaries. On one side, we've got a machine with almost godlike traits. It operates at lightning speed, doing millions of calculations a second, offers near 100% accuracy, massive storage capacity, and pure diligence. I mean, it literally never gets tired or distracted, no matter how repetitive the task is. But juxtapose that against its limitations. A traditional computer has zero natural intelligence, no emotions whatsoever, and most importantly, it cannot make independent decisions outside of what it's been programmed to do.
Which brings us directly to a super memorable concept you're going to see on almost every exam. GGO, garbage in, garbage out. Because the computer can't actually think for itself, right? So if you feed it incorrect data as input, it is going to flawlessly, rapidly, and accurately give you a totally incorrect result. It does exactly what you tell it to do. If you accidentally tell your GPS to route you into a lake, well, it's going to efficiently guide you straight into the water. Section 4. The interesting history of computers. Getting to this insane level of speed and precision took centuries of human innovation. We can actually trace our steps back 3,000 years to the very first calculating device, the abacus, developed in China. For centuries, literally just moving beads around was the standard. Moving rapidly forward, in the early 1600s, John Napier introduced Napier's bones for multiplication. Then in 1642, Blaise Pascal invented the Pascaline, the very first mechanical calculator. But the real game changer happened in the 19th century when Charles Babbage designed the analytical engine. This was the first mechanical general-purpose computer design, and it absolutely laid the groundwork for the digital age.
Section 5. Generations and Types. Following Babbage's vision, technology just exploded through 5 distinct generations. Basically, we've consistently shrunk computers down while massively multiplying their power. The first generation, from 1940 to 1956, relied on giant, room-sized vacuum tubes that generated a ton of heat. The second generation cleverly swapped those out for transistors, making machines smaller and way faster. Then the third generation in the 60s brought us the integrated circuit, or IC. By 1971, the fourth generation gave us the microprocessor, which is the exact same microscopic tech powering the laptop you're probably using right now. And today, we're pushing into the fifth generation, the highly advanced realm of AI, machine learning, and robotics.
Now, within our current generation, these machines scale dramatically depending on the job. For personal use, we rely on microcomputers, your everyday desktops and laptops. Step it up a bit, and businesses use mini computers and mainframes to handle massive amounts of organizational data. But at the absolute peak of human engineering, we have supercomputers. We're talking machines like Param in India or Fugaku in Japan that do the absolute heaviest computational processing on Earth. Things like simulating global weather patterns or complex molecular structures.
Section 6. Computers and Modern Life. Let's bring this all back to the present day. It's practically impossible to find a sector untouched by this tech. In education, we've got smart classes. In banking, that ATM you use is essentially a specialized computer securely managing your cash. In medicine, life-saving MRI and CT scans are entirely dependent on complex processing. Defense systems use them for precise missile guidance, and obviously, the smartphone in your hand right now is an incredibly powerful computer. Kind of funny that we use this monumental leap in human engineering to mostly watch funny cat videos, right? But seriously, whether it's an MRI or a smartwatch, they're all using that exact same IPO cycle we talked about to save time, reduce human error, and connect our world.
Section 7. Exam Prep. Rapid Fire.
Okay, let's do a rapid-fire review. If you're studying this for competitive exams, you absolutely need to lock these next few points in. First up, if you're asked who the father of the computer is, remember the name Charles Babbage. His 19th century analytical engine set the vital blueprint for modern computing.
Next, what was the absolute first calculating device? That would be the abacus, created in China over 3 millennia ago.
When asked about the brain of the computer operation, the answer is always the CPU, the central processing unit. Remember, that's the home of the ALU, the control unit, and the memory.
And never, ever forget the golden rule of data processing. GIGO. Garbage in, garbage out. The quality of your output totally depends on the quality of your input.
I'm going to leave you with this final thought. We established earlier that a fundamental limitation of computers is their lack of natural intelligence. They can't think for themselves. But as we push deeper and deeper into this 5th generation of AI and machine learning, will these purely logical machines eventually overcome that limitation? Will the magic box ever truly learn to think, feel, or decide completely on its own? It's a thrilling and, honestly, maybe a slightly terrifying frontier. Thanks for learning with me today on this explainer. Stay curious and keep questioning the technology around you.